Hello and welcome to the BloodStream podcast, a show serving the greater bleeding disorders community, brought to you by Believe Limited and BloodStream Media, and made possible thanks to our presenting sponsor, Takeda. I am your patient advocate and host, Patrick James Lynch.
And I am your healthcare advocate, nonprofit nerd, and your other host, Amy Board, reminding you to please speak with a healthcare professional before making any treatment decisions.
It really is such a good idea. On today's show, Dr. Radek Kaczmarek is here to discuss a couple of papers that he's recently co-authored, fellow blood brother and fancy doctor man, and the global perspective. Access to gene therapy around the world is the focus of our latest gene therapy segment, this time featuring Dr. Hank Greely from Stanford and Oxford nurse and PhD candidate Simon Fletcher. We've got all of that and more on today's episode. Welcome to BloodStream.
Listeners, thank you for joining us today. And if you like what you hear, please subscribe to the BloodStream Media podcast wherever you listen to those bad boys.
Yeah, do that. Would you please?
Just do
Good
it.
idea.
It'll be great.
I also want to remind you, dear listeners, that the BloodStream podcast is indeed made possible by our presenting sponsor, Takeda. Yes, that's right, Takeda. Takeda has got this website, bleedingdisorders.com, where you can learn all about Takeda's resources for and commitment to the bleeding disorders community. Takeda, Amy, get this, believes in a world free of bleeds.
We love.
We do. We vibe on that big time.
Yep,
and they are dedicated more than ever in their efforts to offer a wide range of programs and support to help patients throughout their treatment journey, wherever on that journey they may be, and you can learn more by simply visiting bleedingdisorders.com. It's all you got to do, bleedingdisorders.com. And for their founding and ongoing support of the BloodStream podcast, I would just like to say, thanks, Takeda.
Thank you, Takeda.
Oh, boy, Amy Board. So let's see. What is it? Today's
It's Friday.
It's BDC Friday, isn't
August 22nd.
It is. We are so we've recorded this ahead of time.
Obviously.
Because we are currently busy in Colorado.
I was about to say. So, yeah, we're
I'm
probably
standing online waiting for a Frappuccino or some kind of delicious treat at a booth.
No.
Yeah, why?
Well,
what else should I be doing?
You're probably doing that, but you have a line of people waiting to talk to you. That is your vibe at these things.
Not until I get some caffeine.
Let me tell you something. Like, we budget Patrick's time. He can't, get to a session in, 10 minutes. We budget, at least 45 because you get stopped all the time.
It is a tricky environment to move through. That is
I
true.
know.
It doesn't help being 6'2" barefoot either because I'm easily spotted in a crowd.
Let me tell you something. Yeah, no, you're seriously,
So that's
It's the
where
whole
we
thing.
are. If
That's
you're at
where
the
we are.
BDC, come track us down. Say hi. Amy and I will be running all around. You've got a session. I've got a session. We're in the program book.
Yeah.
So people can come to those sessions if they want.
It's all I
Stick
get to
around
do.
after.
Come see the science fair at the exhibit hall.
Yeah, we'll be
It's
there a lot of the
baller.
time.
Yeah, so when the exhibit hall is open, the science fair will be open.
And if you do see us, let us know what you'd like to hear on the show. It's
Yes,
always fun to hear
please.
from people who are listeners that say, I'd love to hear more of, or I'd like to
Yes.
hear this kind of interview, or could you
Yes.
do a little more on this? So stop by, say hi, let us know what you'd like to hear.
Yes, please. It was my highlight last year when all of you came up and said hi.
She hasn't stopped talking about it, so. That was a visual joke, listeners. I'm sorry. You missed it. It was a really good face.
It was such a good I'm sure they will zoom in.
All right. So our first segment today, gene therapy, zooming out for a global perspective. Can you set this up for us, Amy?
We'll talk about zooming in.
Hey,
we're gonna zoom
it back out.
Yeah, Hannah Berry is back, our contributor who writes and hosts our gene therapy segment, and we're going to talk a little bit about the global perspective.
Sure.
When thinking about these new treatments, this treatment shift, and in particular gene therapy for hemophilia B. When we talk about global access, we're talking about a wide range of lived experiences and a whole new set of challenges. So you'll recognize today's guests, which are awesome. Dr. Hank Greely is going to join us again. He is a bioethics professor at Stanford, and Simon Fletcher, a nurse and PhD candidate at Oxford. We've explored the psychological impact and ethics and future of gene therapy with these two, and now we're going to get the global perspective. Take it away, Hannah.
Welcome back to Gene Therapy, A Whole New World, the segment where we unpack the promise and the realities of gene therapy for hemophilia. I'm Hannah, and today we are zooming out for the global perspective. So if you've been following along, you'll recognize today's guest, Dr. Hank Greely, bioethics professor at Stanford, and Simon Fletcher, a nurse and PhD candidate at Oxford. You've heard from both before as we've explored the emotional impact, ethics, and future of gene therapy. But before we dive in, here is a quick word from our sponsor. It's a whole new world gene therapy segment brought to you by CSL Behring and their hemophilia B gene therapy treatment. To learn more about gene therapy, hear patient stories, and view additional support resources, visit beyondhemb.com or download B Support wherever you get your apps for more information and to manage your treatment journey. Gene therapy, as we've been exploring, really is something different. It's a one-time treatment with the potential for lifelong benefits. But here's the catch. Access isn't just about science. It's also about systems. And depending on where you live, that system can look very different. So just to put it in perspective, over 80% of people with hemophilia worldwide still do not have regular access to factor replacement therapy. 80%. That's from the World Federation of Hemophilia's 2023 global survey. So when we talk about global access, we're really talking about a wide range of lived experiences and a whole set of different challenges. So later in the episode, we're going to hear from Simon, a nurse who works closely with families in the UK, navigating that emotional side of gene therapy. But first, we're going to circle back to something Dr. Hank Greely said earlier in this series, a line that really stuck with us, and, well, it feels especially relevant as we look at the bigger picture.
So the first two words of any answer I ever should give to anything should always be, it depends. Because we've learned a variety of different lessons, and not all gene therapy contexts are the same.
It depends. That's the honest answer to almost any question about gene therapy I am discovering, because the context matters, and no two situations or areas in this case are exactly the same.
So one lesson we have learned is FDA and the EMA in Europe are willing to approve gene therapies in a rigorous, but ultimately, I think, reasonable way. Some of the diseases are so small that if FDA held to its normal standards for the size of clinical trials, it would be impossible. There aren't enough people in the world with the condition to be able to mount a full phase 3 trial by the standards of most of FDA's work. So I think FDA has been flexible.
But flexible? Well, that doesn't always mean fast. And for patients and families, slow approvals or no access at all, that can feel like an added burden on top of everything else. Though we have seen some real milestones take place, like the FDA approval of a gene therapy for hemophilia B here in the United States that is showing amazing promise. Well, that journey isn't the same everywhere.
I am sure that for those in the disease organization community, it has been frustratingly slow because you've got a loved one with a disease, and anything that slows it down is frustratingly slow. I am sure that sometimes it was slower than it needed to be. I actually think that sometimes it's been faster than it should have been.
One way that some countries are trying to speed up access while still keeping high standards is through harmonization. That's where nations agree to recognize each other's clinical trial data instead of starting from scratch. It's all about finding ways to get these breakthroughs to more people faster without compromising the safety.
Harmonization is a good thing. And biopharma has a whole bunch of international agreements for harmonization. So pretty much all of Europe, Canada, the US, China, Japan, Taiwan, variety of countries all accept clinical trials done in each other. They don't necessarily say you approved it, so we will just blanket approve it, but they respect each other's processes in part because they've agreed on certain things that are necessary in order to make a convincing case.
So harmonization is progress, but the reality is 75% of the global population lives in places that aren't part of these agreements, like much of Africa, Southeast Asia, and even Latin America. And that's from the World Health Organization's 2023 Global Health Estimates. And even in wealthier countries, access isn't always a given. In the US, gene therapy for hemophilia is FDA approved. However, even as early as 2024, many insurance plans still haven't covered it. So this isn't just about borders, it's about infrastructure, policy, and resources.
There are an awful lot of people who are really poor and live in really poor countries that don't have good healthcare facilities. And how are you going to take care of them? And the largest country in the world is now India. It's got 1.4 million people. For about 300 million of those people, which is about the size of the U.S., they're not dirt poor, and they have access to medicine. They're not as well off as Americans, although they're billionaires too. But the other billion live in villages and are dirt poor and are lucky to see doctors. It is already the case that health is grossly unfairly distributed. Healthcare is grossly unfairly distributed across the world. I don't think gene therapy is going to be an exception to that unless or until somehow it becomes magically easy, which would be nice, and people are working on that. But we're not there yet.
One idea some experts are exploring is platform approvals. That's where regulators would approve of a method as a whole instead of starting from scratch every time for each disease. It's a bold idea. It could cut years of work and millions of dollars out of the development pipeline, but also comes with questions, like how to ensure safety without losing scrutiny.
I do like there are folks who are trying to convince FDA to approve a gene therapy platform. So approve an approach to gene therapy, and then without requiring you to prove that the particular disease, the particular genetic change you're making helps a particular disease. That makes me a little bit nervous, but it also has, I think, some real potential, because at least you can avoid some basic questions if everybody agrees, yes, using this kind of viral vector with this kind of CRISPR mechanism, or base editing or prime editing, or whichever of the 1,000 versions of gene editing people are coming up with now, as a general matter works, that could save lots of millions of dollars and lots of months and years of work. We're not there yet, but people, including people at the FDA, have been investigating that. That would be good.
So let's shift gears to the human side of all of this, because access isn't just about treatment. It's also about how prepared somebody feels, the support they have, and what it means to them as a person. In one European study, nearly 60% of people considering gene therapy said they felt emotionally unprepared for the experience. And that's from the 2022 study by the European Association for Hemophilia and Allied Disorders. It's why organizations like WFH and the EAHAD are stepping up, training providers, opening space for mental health conversations, and working to better prepare patients and families. But as Simon explains, there's still a real gap between the need and what's currently available.
I think there are gaps, but I think there are moves to close those gaps slowly but surely. WFH and their psychosocial committee there are making huge strides in that area, and they are having regular meetings in all of the territories around the world to try and get people, healthcare professionals, thinking about the psychological implications of all the treatments, but of gene therapy in particular, and providing and how to provide support to people in that situation. So they're doing an awful lot at the moment.
It's one reason why groups like the WFH and EAHAD are working to create more spaces for these conversations, so training providers can support mental health and help families feel ready for what's ahead. But like Simon shares, there's still more work to do to make that kind of support consistent everywhere.
EHAD in Europe are doing a fair bit with their psychosocial committee there as well. So there are moves to close that gap, but there are still gaps there, and I think that's where the nurses in the treatment centres are really important, basically, because, as I say, they have this psychologically aware care. They're aware of the psychological needs and are aware of what support is available in their area to support people going through and having problems if there are any.
So it's a powerful reminder that gene therapy, it isn't just about the treatment, but about how people experience it. And as the science moves forward, the support systems around it needs to keep pace. That's it for today's Global Check-In. And wow, we covered a lot. From regulatory harmonization to healthcare inequity to remembering who it is really about, the patient. Gene therapy lives in all of these contrasts. You can also find all of these wonderful resources mentioned in today's episode linked in the show notes below. Join us next time as we explore gene therapy in action, real-world success stories. So stay tuned, you don't want to miss it. Until then, it's your girl Hannah, signing off.
BloodStream listeners, this next segment is brought to you by Genentech. There's a new short film out there that's dedicated to moms who care for their sons with hemophilia A. It's an honest and visually striking journey about a mother going through the emotional whirlwind of raising a son with hemophilia A. This story is inspired by thousands of real moms and serves as a thank you for all that they do to make the hemophilia A caregiver community a place of love and resilience. Visit www.hemashort.com to watch the short film. Okay, and now joining us to discuss a couple of his recent papers that he's co-authored, Blood Brother and Fancy Pants, that's what I like to call him, Dr. Radek Kaczmarek.
BloodStream listeners, our guest today is Dr. Radek Kaczmarek from the Indiana University School of Medicine. Dr. Kaczmarek is the co-author of several papers of note, but he's also a blood brother, so he's going to offer a unique experience. The first paper, Gene Therapy for Hemophilia, From Basic Science to First Approvals of One-and-Done Therapies, was co-written by Dr. Kathy High and Dr. Roland Herzog. So Radek, welcome back to the show.
Thank you for having me, Keith.
It's our pleasure. So the first question, what is the genesis of this paper, and how do you see its content benefiting the community in the future?
This paper came out on the 25th anniversary of the molecular therapy. It's a go-to journal for the whole community of gene therapists, clinicians as well as basic scientists who have been trying to develop gene therapies for all kinds of conditions, including hemophilia, for decades now. And in terms of benefits for the community, the paper aims to summarize really all that we have learned so far from a huge body of preclinical data, again, generated over decades for hemophilia, as well as the more recent, although pretty sizable as well, counting more than a decade already, clinical data for hemophilia A and B as far as gene therapy using adeno-associated viral vector gene therapy is concerned. And also taking a look into the future.
So your paper starts in the mid-90s when realistic paths to gene therapy began to emerge. Can you take us back to that time, what was happening in the field, and what drew your attention to it?
Why don't I take you 4 years back, actually, because that's how I see where really the origins of gene therapy for hemophilia come from. That's when the genes encoding coagulation factor 8 and coagulation factor 9 were cloned and put into cell cultures, really, in tubes or other laboratory containers. And when it was proven, actually, that by doing so, you can make those cells produce recombinant factor 8 or recombinant factor 9. That gave rise to one of the major breakthroughs in hemophilia treatment, namely the advent of recombinant clotting factor concentrates. But it also gave rise to this idea that one day, perhaps we would not only be able to put those cloned genes into artificial cell cultures in tubes and laboratories, but perhaps we would be actually be able to deliver those genes into the cells of the patient inside their own bodies and make their bodies make the division factor. That's really the gist of gene therapy for hemophilia. That idea really led to really the first decade of experimentation with various cell types, with various gene therapy vectors. And viral vectors turned out to be really efficient at delivering genes. And at some point, it was a question of which viral vector we would be able to use in the clinic to successfully deliver the transgenes and correct hemophilia in the long term. Adeno-associated viral vectors in the mid-90s and by the end of 1990s turned out to be those vectors.
Now, gene therapy's had cycles of hope and skepticism, but what's kept you grounded or even optimistic over the years?
Well, I guess from the blood brother's perspective, I would say, the community has been hearing that gene therapy would be that ultimate cure that would come at some point. Again, this stemmed from gene cloning of those factor 8 and factor 9 genes, and it really fundamentally sounded like a simple idea, but easier said than done. In a number of those 5-year cycles, I would say the community has been hearing the cure would come at some point. And also, gene therapy very early became almost synonymous with a cure. That's really has been the expectation of the community, that gene therapy would be that ultimate one-time treatment. And I guess that kept many people grounded, especially in the hard times, looking into the future.
One of the most appealing ideas is that gene therapy could be one and done. So, how close are we to that reality?
We are closer than ever, that's for sure. And it may be the reality for some individuals, but not all. And that's where the disappointment part comes into play. Because it turns out that the current gene therapies have shown wide variability of efficacy from no response to raising factor levels to moderate, mild levels, but in some individuals, even normalizing them or even going over the normal ranges. So that's a pretty wide range, and it's unpredictable where individuals will land with their factor levels after dosing with the gene therapy. So that's a big unknown, and that's a big difference compared to the legacy therapies, which are quite predictable in comparison and how they work. And that's also one of the major barriers in decision making on whether to try gene therapy or not, because it kind of is one and done at the time, but for the wrong reasons. The reason being we are not able to repeat it, not because it works so well that we won't need any correction anymore ever. The idea for it being one and done is that we give the therapy once and it results in a hemophilia free mindset for life. That's the ultimate goal for gene therapies. But at this point, we have over a decade worth of data for people with hemophilia B, where hemophilia B gene therapy has been remarkably durable, and those factor 9 levels coming from the gene therapy have been stable. Many of those individuals actually, for the one approved product that's still on the market for hemophilia B, almost 80% of individuals have factor 9 levels, stable factor 9 levels over 12% in a quite protective mild range and higher. And for hemophilia A gene therapy, it's quite a different story. For the approved product, most individuals have experienced factor rate decline year to year, even though initially in the first year after gene therapy, many of those individuals had normal factor levels, but then in the majority, they kept declining. There is some hope now in the after 7 years of follow-up for the phase 1/2 study of that approved hemophilia A gene therapy. It looks like maybe they are plateauing finally, so perhaps those patients will not go to the baseline, but then some individuals might need to return to prophylaxis, and actually in the larger phase 3 trial involving more than 130 individuals, a significant number of those individuals, 80%, if memory serves, return to prophylaxis because of the decline they experienced. The remaining individuals still express factor 8, and it remains to be seen if they plateau at some point or or will need to go to a standard prophylaxis. So completely different stories for hemophilia A and B. Neither of the therapies is reliably curative at this point. Hemophilia B seems curative potentially for some individuals, those who, for reasons that we can predict and cannot really explain, fully land in the normal range or say upper mild range, but that's not the case for hemophilia A. The correction is it's still a long-term correction in the comparing to standard therapies, but it looks temporary at this point.
For hemophilia A, the challenge of factor VIII expression is well known. What are some promising engineered variants being developed to overcome that?
Factor VIII is a finicky protein on many levels. It's much bigger than factor IX. The gene is much bigger, which imposes one of the limitations on the AAV gene therapy. It required some major engineering already to even be able to put the factor VIII gene into the AAV vector, since the full-length gene wouldn't fit in that vehicle. So we have already some engineering done there. And what we do is we delete one of the major parts of the protein called the B domain, which is not essential for its procoagulant activity, for its role in the blood clotting, but does play some role in the way factor VIII is made inside the cell and in the way it is being able to be moved outside of the cell and perform its function in clotting. And perhaps one of the problems with factor VIII and making it in any cell type is that it tends to get stuck in cells, really. It tends not to fold properly, basically assemble properly inside the cell. That makes it harder to move it out. And there are a number of variants that address that problem and make factor VIII more soluble, less prone to those folding issues, and facilitate expressing it out of the cell to the circulation. I think most approaches focus on that, on the ability of factor VIII to fold properly and secrete. There are also approaches addressing its stability. Normally, as part of its processing, it gets broken up into two chains, but when it's expressed as a single chain, which can be achieved by removal of, again, a part of the protein that makes it prone to be cleaved by enzymes inside the cell. If it can be expressed as a single chain, it improves its stability, and perhaps that can also make gene therapies using such variants more efficacious. It potentially all boils down to being able to use lower vector doses. This is something that we've seen in hemophilia B. Both approved gene therapies for hemophilia B, the one that's still on the market and one that unfortunately has been withdrawn recently, relied on the so-called Padua variant of factor IX, and introduction of that variant made it possible to achieve much higher factor IX levels than using a wild type standard factor IX coding sequence. And one of the reasons that was possible is because we're able to use lower vector doses. And using lower vector doses is associated with less toxicity and less immune responses. And we've seen that in multiple preclinical studies and in the clinic as well. There is correlation. So the overall aim for those bioengineering efforts, if you will, is to be able to make more protein, basically more transgenic protein inside of the patient's cells by using a lower vector dose.
Well, that seems like a great transition to another paper that you co-authored about the role of immune treatment in the durability of factor expression post-gene therapy for hemophilia A. So, a couple of questions. Could you provide an overview of the study's findings?
Immune responses to AAV gene therapy is one of the major limitations that actually only came up in clinical trials. This is something that had not been seen in preclinical studies in animal models. Initial clinical studies saw success with managing those immune responses using corticosteroids. And this has been a go-to intervention for multiple subsequent trials, including trials that led to approvals of the products that are now on the market. In some individuals, early we saw success at rescuing factor expression, because again, the problem with those immune responses was that primarily in some individuals, they were associated with loss of factor expression early after vector dosing, within weeks to within the first few months after vector dosing. And more recent clinical trials were less conclusive in terms of how helpful immunosuppression is using corticosteroids. In some individuals, it seemed like it helped, and some it didn't. And in some cases, there was very poor correlation between immune responses and liver enzyme elevations and factor expression changes in individuals. So there have been a lot of effort put into trying to develop better immunosuppression protocols. And the study you are referring to was one such effort that tried to basically see if we can prevent immune responses more efficiently if we introduce immunosuppression much earlier than other studies had so far to that point. And in that particular study's case, that was concomitantly with vector dosing. Most other studies either did this reactively when there were signs of factor expression loss or elevation of liver enzymes, or if they did this prophylactically, they still did this typically a few weeks after vector infusion, not concomitantly with vector infusion on the same day. Surprisingly, not only it didn't help at all, but actually seems to have made things worse. Actually, individuals, I think there were 23 individuals enrolled into that study, and 21, I believe, had liver enzyme elevations despite that prophylactic immunosuppression regimen. And their average factor VIII levels were lower than in the pivotal phase 3 trial. Upon analysis, this could not be explained by the batch-to-batch variation in vector preps. So it looks like, again, immunosuppression might have actually made things worse here. And again, if we go back and take a closer look, go deep into the weeds, looking at preclinical studies, there are complex scenarios in which actually immunosuppression may be a double-edged sword in that way. In the preclinical models, sometimes it meant actually inhibitor development. Fortunately, this has never happened in connection with immunosuppression in the clinic in patients with hemophilia.
So, what does this research mean for the future of gene therapy in hemophilia?
One thing it means is I don't think aggressive prophylactic immunosuppression protocols will be used. It seems that it just is not effective, and immunosuppression comes with its own adverse events, with its own treatment burden on the patient, especially when it's a prolonged regimen. And again, in some cases, the prophylactic regimen was followed by reactive immunosuppression, which meant that in response to ALT elevations that occurred anyway, which meant that individuals had to spend many weeks and many months on corticosteroids. So this isn't ideal. If you don't have to use immunosuppression, if it's not likely to help in everyone, you probably shouldn't use it.
That was incredibly informative. Dr. Radek Kaczmarek, thank you so much for joining us on BloodStream. We look forward to hearing what listeners have to say about this. Thanks again.
Thank you, Keith.
Thanks again, Dr. Radek Kaczmarek, Dr. Hank Greely, and Simon Fletcher for joining today's program. Thanks, as always, to our presenting sponsor, Takeda, bleedingdisorders.com for more. And thanks to Genentech. Remember, visit hemashort.com to watch that short film. It's worth your time. We could not produce this show without your support, and we are grateful for it. All right, Amy, we've knocked down August. What is now coming up September 12th? That's the next one. What can listeners expect to hear?
I honestly, let's just get through the summer. I don't know.
Okay.
We're just going to keep you in suspense. The fall is going to rule. There's actually a lot of things in the can, but we're not,
Yeah, we have too many things. We just haven't decided what's happening yet.
100%. It's just keeping you in suspense, people. But let's just get through the summer. Oh, my God.
All right, deal. Fair enough. We're almost there. Labor Day's around the corner.
Woo!
Is it you can't wear white after Labor Day?
After Labor Day, so
okay,
get that white in.
Yeah, wear it. Wear it. So,
I don't know. I feel like no one does that anymore.
I don't know why anyone would in the first place. What's the point?
White jeans are popular.
Really?
I think they're terrible, but you see them everywhere.
I am so bad at walking around and being part of society. Yeah. I don't notice things.
Oh, okay.
That's why
I do a lot
of
online shopping, and there's just so many white jeans.
Wow. Okay. It just seems dangerous to me. I don't understand it.
Yeah.
But
reckless.
That's the best way to describe it. It's reckless. It's really reckless. Well, With that,
Yeah.
that is all for this episode. Be sure to subscribe to the BloodStream podcast wherever you listen to podcasts to get more conversations like this delivered to you the moment they go live.
And loyal listeners, as always, if you would like to join in our conversation about white genes, email us at mailbag@bloodstreammedia.com. That
Subject
is the
line,
place.
white genes.
Yeah, it'll come directly to us. You can also find us on social media. PJL and I are on there. And you can find us on our network pages, BloodStream Media.
Nice. There you go. I am your host, Patrick James Lynch.
And I'm your other host, Amy Board.
And until next time, take self-care of yourself. Bye, everybody.
Bye-bye, y'all.